So guys, as you know, in my users data.csv file, let me show you the file only. In my users data.csv file and cards data.csv file, we have a lot of numerical values. And I want to make sure that those numerical values stays as numeric values. If I go to my users data.csv, you can see my yearly income. For example, again, I have to select all to see all the features. Okay. So I have to go to this yearly income, and you can see this is with a dollar sign. So of course it is not a number, it is a string. Similarly for per capita income also, for the total debt as well. Oh my god, this person has took a big debt. And then we have credit score, which is fine, but still there are three values which I have to convert into numeric type. Similarly in cards data also, we have the credit limit, which I want to convert to a numeric type. And there are some other things which I want to change or I want to feature engineer over here. So for that, we are going to use Spark. To be precise, in Python, we use API for Spark, which is called as PySpark API, which allows us to use the features of Spark in Python. We are going to say PySpark.SQL import Spark session. This is basically like you are creating a Spark session, and I'm going to create it very soon. So once you create a Spark session, you can use the functionality of Spark. And once you close the Spark session, you will no longer be able to use the functionalities of Spark. So it's like you create it and then you also stop it. Okay. So it's not like pandas. Over here, you have to first create the session. So for that, we are going to say PySpark.SQL import Spark session, and then PySpark.SQL.functions. And in that, what I'm going to import is call function to fetch the columns in my CSV file or table or data frame. And then we are going to use regular expression replace, because guys, why we are using regular expression? What is the use of regular expression? It handles the characters, the numbers. In general, you can basically play with your string using regular expression. Okay. And then we are going to use toDate, because our date is also of not type date time. It is of type integers, or I would say text. So I want to convert that text or string type into a date time type. And then we have the when function. After that, we have the types as well, and we are getting the float type, because I want to set the updated columns, which is my credit limit, yearly income, total debt, or per capita income, to type float. And that's why we are importing that as well. I'm really sorry. I don't know why my nose is suddenly itching. So the very first thing that we are going to do is, just a second, I need to scratch my nose. I don't want to make you feel gross about it. So yeah. It's done. Of course, I didn't use my hand. I have the clothes with me. Don't worry about it. I stay hygienic as possible. So now we have the initialize Spark session. Over here, we are going to initialize the Spark environment. And the way we do this is by creating an instance for the Spark session.builder. And we are passing the app name as data processing, because over here, we are going to process the data. You can give any name. It doesn't matter. Either you can create the Spark session, or you can get the existing Spark session if there was some session which I already created in above code. Okay. So I can get it over here, or I can create it over here. And then I will assign the file locations for all three files in the dataset. And where are my files? My files are stored over here. /files/table/mx filter transaction.csv. Then we have this cards data.csv, and then we have this users data.csv. After doing it, so as I said, after doing this, we are going to load the dataset from the cloud storage. And once we are done with that, we will convert the data into a data frame. Cards data contains card detail like credit limit and PIN change information. So what we are going to do is, we are going to create a data frame as df cards, and we are going to, instead of using pandas, now we are using the Spark over here, spark.read CSV. In this, we are passing the CSV file. And the two other things that we are passing is basically my header and my info schema. So what is header? Header will basically convert my first row, which was basically the headings for each of my column, into a heading. Otherwise, PySpark will not understand that the first row is heading. So you have to make sure to make the header as true to tell the PySpark that my first row is containing the heading and not the data. Info schema. Info schema will make sure that my PySpark will understand or try to evaluate the data type for individual columns. Otherwise, it will not do it. Okay. Similarly, we are going to create the data frame for our users data. Just like we did for the cards, we are going to say spark.read.csv. We are going to pass the location, file location of our users data. And then we are again going to say header is true and info schema is equals to true. That's great. After that, we have the MX filter transactions from our previous work just before this, I would not say session, but yeah, we saw that. I assume you saw that. So after that, we are going to repeat the same step, and then we will say that header equals to true and info schema is equals to true as well. So now we are going to perform some data processing. So as I've told you, the first thing that we see as a problem is like our numeric values like credit limit, yearly income are of type string, and we have to convert that. But there are some other problems as well. If I go to my dataset again, if I go to this users data.csv file, or I would say cards data.csv file, and I select all of my columns right over here, and I go to my last column, which is card on dark web. Here you can see all of my cards are not on dark web. All values are false or no, and there is no true value. If there is no true value, if my data set is constant, if my column is constant, should I consider it? Well, it will not make any sense. So what I will do is I will make sure that I drop this column. How do you drop the column? You simply pass dot drop function. In pandas, over here also, we have the beauty of Spark, which allows us to say that df cards equal to df cards.drop, and I'm dropping this particular column over here. Now, I want to remove the $sign. So to clean the credit limit by removing the $sign and converting into float, the PySpark offers us a feature which says that df cards, in that I'm going to say df card dots with column, and I'm going to select my column as credit limit. I'm going to reg replace, I'm going to use this function, and I'm going to pass this column over here. And what I'm going to do is I'm going to replace this particular $sign with nothing. Okay. So I hope you understand this, what is going on over here. Inside my reg replace function, I'm first passing this column, which is my credit limit. And then I'm replacing the $sign with nothing. And then I'm casting it. Typecasting means converting the data type into float type. So I hope you understand what is going on right over here. And yes, after that, you have to come down and you have to basically do the same thing, but this time you have to select the open account date and you have to convert this to date. So, we have imported to date over here. This is the function available in pyspark.sql.functions. And then we are going to select this account open date and we are going to convert this into month year format. That's it. Now we are going to flag if pin change is due if last change was 7 years ago. Now why I am passing 7 years ago? Because this dataset was last updated 5 years ago. So if I will say that check before 2 years, then you will get all values as no, because this data was updated last 5 years ago. So in order to check whether anyone changed their card in last 2 years, you basically have to add this 5-year gap of data because it's not updated. And then you have to add the 2 years to check whether people are changing their cards in every 2 years, or to check whether is the pin of card not changed in last 2 years. So to do that, we have to take the 7 over here because the 5 is my not updated value, because in last 5 years this data was not updated. So last updation was before 5 years, so not update. And then I have the plus over here, 2 years, to check whether users are changing their data pin in the last 2 years. And using 2025 as our base context, we are checking that df.with column pin change. And if the pin changed, I'm creating a new column over here, by the way. And the way to do that is pretty simple. You have to just pass the column over here, or the new column name. And we are passing when function over here. When the current year is less than current year minus 7, then I will pass yes, pin was changed. And if this particular thing over here, which is my pin change due, the current year is not greater than this value, which is 7, it will basically pass no, pin was not changed. So it's a very basic function that I have created, a user-defined function. You can check it out on your side as well. Easy to understand. Similarly, we are doing the same thing with the df users. In that also, we are using regex replace function to basically remove the $sign. Similarly for the yearly income and for the total debt. I'm also creating a new column just like I created over here as year pin change last to check whether people are changing their pin in last 2 years or not. And I'm doing the same thing over here. I'm creating a retirement status. As I already have current age and retirement age in my users data, you can see over here I have the current age and the retirement age. So from that I can gain a new variable as retirement status. If the retirement age is more than current age, that means the user is not retired. But if my current age is more than the retirement age, that means the user is already retired. So I'm going to add this new feature as well. And similarly, we are going to use when function over here. If current age is greater than retirement age, then I'm going to pass retired. Otherwise, I'll pass not retired. Okay. So make sure also over here, pin change due is my new column and this is already available column. So sorry for my mistake. Pin change due is going to be my new column. So over here, it is going to check whether the last year was less than this year. If yes, then it will pass yes. If this is not true, then it will pass no. I hope you understand. Okay. And after that, we are again, after creating the retirement status, we are doing one more thing. And don't worry, I will put this code in the GitHub link so it will be easier for you to use it. This code will be available inside the folder. So I have created several folders like statistical analysis. I will create one more folder as Databricks. Over there, you will find all these things. So then we have this df users and df users.column. I'm creating a new column as age group. In that, I'm going to say that whether current age is less than 30. If that is the case, then user is between the age group of 18 to 30. And again, I'm passing when current age is less than or equal to 45. The user group will be, age group will be between 31 to 45. And similarly, I'm doing it for the rest of the values. So what I'm creating is I'm creating a variable as age group. And this is a categorical variable having 4 values as 18 to 30, 31 to 45, 46 to 60, and then 60 plus. So you can do that. Then we have this calculate debt to income ratio. So guys, suppose a person is having a yearly income of 50,000 US dollars or 50,000 rupees or any other currency type. And he is taking a loan of $5 lakh. So although the income is less and the debt is a lot. So if I try to justify his debt ratio over here, it would be like he's earning only 50,000 and he's taking a debt of 5 lakh. So it's like almost, I would say 10 times higher. Okay. So for such users, taking debt is risky. But if there is a user having a yearly income of 5 lakh and he is taking a total debt of 5 lakh, so for him, it is not that scary. He can pay off the loan if he doesn't spend for an entire year or if he tries to save half of his income for 2 years. But for a person having a 50,000 income, it will be really scary. So that is why we have to consider this parameter over here instead of individually considering total debt and yearly income. So that's why we are taking the ratio of total debt and yearly income and we are storing this particular ratio inside my debt to income ratio, which is a new column that I've created. And yeah, after that, we are again removing the $ from the amount section of our MX transactions. Since in my transactions data.csv file, which we initially used to get this MX transaction file, you can see over here, the amount is of type $. So it's of type string. So I also have to make sure that I clean it. And then we are going to show the first 5 values to show that my data is good. Okay. So we use .show function and we are passing how many rows do we need to show. And truncate is like, we just want to show it in the correct order, like in this order. Don't worry about it. Just ignore it. Okay. So by doing this, we can check the updated data frames, not CSV file, because we have not basically converted into CSV yet. We are just keeping it as data frames. And then we are going to count the total number of values. For the cards count, it will be 6146 because we already checked it in our previous video. We have 6146 unique card. We have 2000 unique users. So it will be 2000. We have, I don't know, around 5,70,000 or somewhat like that value for the total number of transactions with the card brand MX. We are going to pass this. And if you want to, as I've said in the starting, that I have to create a Spark session in order to use PySpark, which we created over here as Spark session.builder.app name, and then we assigned the app name. If that name was already existing, get it or create using get or create function. But in order to close the Spark session, we have to use it spark.close. Spark session remains active since we keeping the data frames in memory, because I want to use this data frame in my machine learning model which I'm going to create. I will not stop the session right now. But you have to make sure, in order to save your memory and cluster usage, you have to close it using a simple function which is spark.close, which we will do later on. Okay, so let's see the output over here. It's a bit messy to understand, but it's completely fine because we are Ronaldo fan. Very bad joke. I'm really sorry about it. By the way, I'm a fan of Messi. So over here, you can see we have the first pre-processed cards data. It's not easy to understand what's going on over here, but let me just show you what's my output is. We have the users data table now, which is having the first 5 rows. Then we have the MX transaction, which is somewhat easier to understand. We have the fraud label. We have the MCC code over here, which is my merchant unique code assigned by the card brands. Over here, it is assigned by my bank, not card brands. Okay, but still card brands usually assign it to track the type of transaction that their users are making. After that, we have this card data frame has 6146 rows. As I have told you, in the bank, we have only 616 unique card issued to the user. Now just understand guys, we only have 6146 card. In real life, I would say I stay in Chicago. Just imagine the number of cards and imagine the number of transactions that happen. So that's why we need to use the not the community edition over there, because even with this simple transaction file having only 80 lakh transaction to process basically for the machine learning model, and in total also there are only 1 crore 30 lakh or somewhat around 13 million transactions. Still we are not able to do that, and it takes around 30 minutes to process. Just understand the power of big data analysis and PySpark when you work in an organization having billions of transactions every day. So yeah, that's why we are studying Spark instead of Pandas. Then we have 2000 unique users over here. We already know this. We only have 2000 unique client in our bank dataset. We have 5,72,424 unique transactions with MX card. And then we are going to perform the machine learning model on this MX card, and the target variable that we want to predict will be my fraud label. So now let's see how we can apply the machine learning model of classification to this final data set, which is pre-processed and feature engineered. So let me drink some water and let's start by looking at our machine learning model now. And you should also drink some water because you have done a great job if you're staying till this point of the video.